Hello, I'm Frédéric Legrand from Neuron Company in Switzerland. The goal of this presentation is to show you how NetApp can be used for data volume in a Docker cluster. Data volume are designed to persist data independent of the container's life cycle. NetApp has developed a volume driver for Docker that is able to pilot volume creation in a NetApp Storage Array. In this presentation, I will show persistence with a MySQL database in Docker Datacenter. I will also show you how snapshot can be used with Docker. So let's start the presentation. Here you can see I have a 2-node cluster of Docker engines. These 2 Docker engines are named Docker 1 and Docker 2. Each one is configured with a NetApp volume driver, and this volume driver is configured to point to our NetApp Storage Array. Our NetApp Storage Array is configured with NFS protocol. The policy is allowing our Docker nodes to mount NFS volume. So all NFS volume created will be accessible by all the containers of our Docker nodes in the cluster. So for the moment there is only one volume, the root volume. So we will create an application that will create Docker volume in this view. So let's create the application. So the application will be named DB, and the configuration is here. I'll copy paste it. So this application is composed of 2 services, phpMyAdmin service and MySQL service. phpMyAdmin service will be used to create some stuff in the database. phpMyAdmin web interface will be accessible on port 8080. MySQL service is based on the official MySQL image you can find in the Docker Hub. So MySQL container will mount a volume named MySQL. The definition can be found here. We will see that later. So the volume named MySQL will be mounted in the default location of MySQL data files. So all the data files of our database will be stored in this volume. Here you can see I will constrain MySQL container to run on the first node. We will see later that I will force the container to run on the other node. So for the volume MySQL here is defined here. He's based on the NetApp volume driver, as you can see here, and he has a size of 2 gigs. So let's start the application right now. So as you can see here, the application is creating a volume with a NetApp driver. So let's check in the NetApp Storage Array if a volume has been created. So a volume prefixed with Docker underscore has been created in the storage array. The Docker underscore prefix can be configured and changed in the NetApp volume driver. Here we check that the size is 2 gigs. So now we can see that the application has been successfully deployed. So we will connect to the phpMyAdmin web interface to do some things in the database. So as you can see, the phpMyAdmin is running on Docker 2 because we did not force this container to run on Docker 1, but MySQL container has been forced to Docker 1. So we have to retrieve the IP address of Docker 2, so node Docker 2, the IP address is here. Now we have to connect, sorry, I just have to copy paste this IP address with port 8080. So now we have to connect to the database with the password we specified in the compose file. So here you can see 4 databases. This is the default databases in MySQL startup. So now I will create one more database, DB1. Let's create, and I will create a a table with one row, table 1. Okay, let's create, and I will put some data in this table. Okay, as you can see here, we have a database DB1 with a table 1 with some data inside. Now I will show you how data persistence works with Docker. So I will destroy my application. So destroying an application is not destroying its volume. So we can see DB MySQL volume, there is 2 because there is 2 nodes. So we have still our volumes. The application disappeared. So we can see that containers has been deleted, but not the volume where data is stored. Now I will create a new application. So I just have to copy paste some content for my compose. And this is the same application, but we will force it to run on node Docker 2, and we will use the same volume. So let's create this application. So this application is not creating a new volume because it's already existing. So now we can see that 2 containers are running on Docker 2, since we forced MySQL engine to run on Docker 2, and we did not force phpMyAdmin to run on Docker 2, but it created randomly on this node. Now let's go to the phpMyAdmin web interface, log in again. So we can see there is still our database, and we removed the container, but the database is still here. So now I will show you a very interesting functionality of NetApp Storage Array. We can do snapshots. So I will perform a snapshot of my database. Before creating the snapshot, I have to stop the database to get a current consistent state of its volume. So the database is stopped. Now I will create a snapshot of this database, of the volume of this database. So the snapshot backups the current state of our database. So now we'll start the container again. So the database container again. So once it's started, we will connect again to phpMyAdmin, okay, and we will create another database. We name it DB2, and we will create a table 2 with 1 row and with data inside. Okay, so we can see we have DB1 and DB2 in this MySQL engine. Now I'm not happy of the modification I have done, and I want to go back to the snapshot state when I perform the snapshot. So it's a previous state of the database. So let's stop again the MySQL container to get a current to gain a consistent state, and we will restore the snapshot. Okay, so the snapshot has been restored. Now let's start the container again, and let's check. So I have to log in again since it has been restarted. And let's check that DB2 disappeared because it was not present when we performed the snapshot. So, in conclusion, the data persistence is mandatory for production environment. NetApp driver is an easy and efficient solution to provide an enterprise-grade storage for Docker. Thanks for your attention and see you for the next presentation. Bye bye.